GS4 variable frequency drives have two analog outputs, and either analog output can be used to represent any of these things: the output frequency, motor speed, or power factor. They can show you what the analog inputs are doing, be commanded from serial Modbus, Modbus TCP, or Ethernet IP, and you can even enter fixed analog output values directly from the keypad, which is handy when you're trying to calibrate your system and just want to force a known output for test. Analog output 1 is voltage only. Switch 1 on a terminal board selects if it's positive voltage or plus and minus voltage. Analog output 2 can be switched between voltage and current using switch 2 on a terminal board. Could you use analog output 1 as a current output? Sure. You just have to provide an external 500 ohm load in series to get the 0 to 20 current output. Using parameter 453, you can even change it to a 4 to 20 milliamp loop. Again, that assumes you connected an external 500 ohm load. Is this parameter really changing the output from 0 or 4 to 20 milliamps? No, not really. It's just scaling the voltage from 0 to 10 volts to 2 to 10 volts. So when you add that external 500 ohm load, you get the correct currents. So if you want to use analog output 1 as a straight voltage output like the switch says, make sure that parameter 453 is at its default setting of 0 so you get the full range that you expect. Analog output 2 is identical to analog output 1 with one exception. The switch really does switch output 2 between voltage and current. Other than that, the exact same rules apply. If you're using the voltage setting, make sure the scaling is set to 0 to 20 so you get the full voltage range. If you have the switch set to current mode, then parameter 457 switches between 0 and 4 to 20 milliamps. Analog output 2 has one other benefit: bias control. That is, you can tweak the output level to accommodate anomalies in your system. Let's do an example. Suppose we need analog output 2 in current mode. We'll use the default 0 to 20 milliamp range, and we want to output a fixed level. If we tell output 2 to go to 50%, sure enough, it gives us 10 milliamps. Perfect. But suppose our system really needs for the 50% level to be at 11 milliamps. Using parameter 459, we can add in an offset or bias to make that value whatever we want. Let's bump it up a little. Yeah, a little bit more. A little bit more. Bingo. Now, when any source that's driving analog output 2 is at 50%, analog output 2 will send out 11 milliamps. Cool. You can also change the gain of the output from 0 to 500%. So if we double the gain, the output would look like this. If we reduce the gain to 50%, the output would look like this. One side note: if you're writing this value from Modbus TCP or Ethernet IP using one of the optional COM cards or the integrated PLC, note that there's an implied decimal. So to get 50%, you would write a 500. To get 500%, you would write a 5000. You can even change the behavior of the output. These parameters tell the drive only to output positive numbers, 0 for negative numbers, or automatically shift the midpoint to the midpoint of the range so you can represent plus and minus. This is really intended to modify how to present the analog outputs when the motor is going in reverse. Do you just want to see positive values for forward and reverse, no value for reverse, or do you want to use half the range to indicate when it's going in reverse and half the range when it's going forward? Before we go any farther, take a look at this chart in Appendix C. It shows you everything you need to know about analog output 1 in one quick reference. All the associated parameters, their options, and default values in one convenient place. And there's an identical chart for analog output 2. The only difference is it has that extra bias parameter. We just did an example of using the fixed value as a source. We just put a 13 in parameter 450 or 454 for output 2, and then the value we want to output in parameter 460 or 461. If you make the source one of the optional COM cards, then you can set the output value simply by writing to this memory address via Modbus TCP or Ethernet IP. If you're sending commands via the RS-485 Modbus, you write to the same address. In both cases, there are two implied decimal places. So to output a 50% of your max range, you would write a 5000. It is important to understand you only get one or the other. If you choose the RS-485 port by selecting an 11 for this parameter, then writes coming from any of the COM cards will be ignored. And vice versa. If you choose a 12, then writes from the RS-485 port will be ignored. You can also output the analog inputs, the power factor, and anything listed here. Most of the time, you'll probably want to monitor the output speed or amps or frequency. Regardless of what you're monitoring, all of them end up in one place that then goes through the same gain, bias, and negative value handling regardless of the source. And that includes writes from the PLC. When the PLC writes to one of those dedicated analog output addresses, it also goes through all this stuff. And remember, if the PLC references an analog output, whatever you select here will be ignored. Which raises an interesting question. Instead of talking to its dedicated output register, could the PLC tell the drive parameters to go to that fixed value and then send its output by writing to this guy? Sure. The cool thing about that is now the PLC doesn't take output control away from the drive. So the drive's analog output source parameters can still be used. And the PLC can switch these to anything at any time. Maybe for one operation you need the analog output to represent output frequency, but for another you need for it to represent the output current. The PLC can switch between these all day long, but only if the PLC never references its own dedicated analog output register. Once that happens, nothing you or the PLC select here will work. Which is why this parameter is so important. At a glance, you can see if the drive thinks the PLC owns the analog output. If this block is solid, analog output 1 is owned by the PLC, and all of these will be ignored. Whether you selected them or the PLC did, doesn't matter. If this block is solid, analog output 2 is owned by the PLC, and any function you select here will be ignored. So keep an eye on this analog output mask and consider using the trick of having the PLC control the drive parameters instead of its own dedicated register. That way you get both PLC and drive control. And there's one other side benefit to controlling analog output parameters from the PLC. If the PLC writes to its own dedicated register, that's a write-only operation. If the PLC tries to read that value back, it'll get 0. On the other hand, if the PLC uses the drive parameters to output a fixed value, it can read the value back. This snippet of a chart in section 2 of the user manual shows how the analog outputs share an analog common, which is the same one as the analog inputs, by the way, and that any cable shields should be connected to chassis ground. And there's also a reminder to make sure that the switches on the terminal board are set to give you the output range you need. Positive voltage or plus and minus voltage for analog output 1, and voltage or current for analog output 2. The analog outputs are located here on the terminal strip, and remember, if you remove these 2 screws, you can pull out the terminal board to make your wiring easier. Then just slide it back in, reinsert the screws, you're ready to go. Click here to learn more about GS4 drives. Click here to learn about AutomationDirect's free support options, and here to subscribe to AutomationDirect's YouTube channel so you'll be notified when we post new video content.